All right. Cool. We are looking at question number 2 for the mechanics. We're at the 2020 exam. I'm trying to pick things from the same exam paper so you can see how the questions fit together. I believe we did some of question 2 previously because we talked about the dropping of the helmet and the conversion of kinetic and gravitational potential energy. This is just the beginning bit looking at work and power. So we are thinking about firefighters. They climb up the sky tower. We have Lynn Lee, who is preparing for the event, climbing up the stairs. They've given us a height for the stairs, and they've also told us her mass and her time to climb those stairs. What they want us to do is to compare the work and power done on each day. So you should calculate the work done on each day and also the power. So these are some new equations that we haven't talked about yet. Remember that they are going to give you this formula sheet at the beginning. And what we need to do from this formula sheet is figure out which ones are related to work and which ones are related to power. Most of them are going to make sense variable-wise. We've used this one here for velocity. We've used this one here for acceleration. We've used this one here for forces. We've used this one here, we haven't used this one here. I'll talk about that one today. That one's pressure. I'll talk about how I know this one's pressure and how this one is power. We have P for pressure and P for power, so that can be quite confusing, so we need to be mindful of which one we're going to grab for those two equations. This one is gravitational potential energy. This one's kinetic energy. This one is work. This one's gravity, and then this one's for pressure. So really important that you know what these equations are used for because they're not going to label them for us. So W is showing us work. So with work, we are thinking about the force times the distance. So how much do I have to do that? How much am I kind of working against that force over a set amount of space in between? So let's copy that equation down. I find my camera. There we go. So for the work calculation, we're doing work equals force times the distance. And this is known as a two-step problem because what we're going to do is use the answer from this here, and we're going to use that to figure out the power. So power is work divided by time, which makes sense with what we're looking at when it comes to these information. So power equals work divided by time. And when I look at this information that's been provided for me, we have the mass, we have height, and that's going to refer to our distance in this case, and we have time here as well. Yep. Yeah, let me get you a note. Are we okay with that so far? And how I translated that all across. All right. Cool. That's some things to keep in mind. The other things to keep in mind when we're looking at this is that we need to figure out what the F value is for the work, so this F value, and the way we're going to find it is by using the force of gravity. So force for the weight is equal to mass times the acceleration. Instead of using any sort of acceleration value, we're going to be using the gravity value. And that's because we're calculating basically how she walks up the stairs and how much work she needs to do to go up those stairs. So for our force, we're going to use F equals M times G. So basically, we're calculating the weight of Lynn Lee with her equipment, and she's climbing up 25 meters, and we're trying to ask ourselves how much work is she doing to climb those 25 meters with the weight of herself and of her equipment. Are we okay so far with that? Okay. So let's plug in those values. So we have F equals mass, which is 80, times the gravity, which is 10. So her force is 800 newtons. Now, the mass that she's carrying on both days is exactly the same because she hasn't changed weight and she's not picked up extra equipment. So we can use this for both day 1 and day 2. We good? Okay. Next thing we calculate is the work that she's done on each day. So W is going to be equal to 800 times the distance she traveled, which is 25 meters. So we do that multiplication. I'm going to find my phone because I don't have a calculator on me. All right, 800 times 25. So 20,000 joules. That's the unit for work because joules is referring to energy. Is she going to be doing the same work on both days? Yes, because she's traveling the same height. So same work on both days. Say math and distance stay the same, so the work is the same on both days. What we notice, though, from day 1 to day 2 is that she's able to do that climb a lot faster. So being able to do things faster is going to affect the power. So power, so this is day 1, power is equal to the work she did, 20,000 joules, divided by the time. In this case, the time is 50 seconds. So that will be 400 watts of energy. Day 2, we did the exact same calculation. Power is 20,000. In this case, we are dividing it by 30 because she's only taking 30 seconds to do that. So roughly 667 watts. So she's outputting more energy or more power on the second day because she's climbing faster. Yeah. I do have a fourth one ready to go. When is the draft get along? You go along at the end of the day if you feel like you've done good work. Or end of the period. All right. Cool. So what are we thinking about is the reason why she outputted more power, and the reason why she had more power on this day is because she climbed those stairs faster. What's that word? Which one? Off the pill. Because. Oh. Yeah, that's just maybe shorthanding because. All right. Questions, concerns, or comments about that first one? Or are we okay with that? All right, keep going. Yep. Okay. Just want to show you guys the marking schedule for this question because I think it's always good to see that. And my computer's being a pain. Let me get my mouse and see if it'll behave itself better. Behave. Try this. There we go. Cool. Question 2. Here we go. All right, here's the marking schedule just so you guys can see it. So we have information. We've done the right calculation. We can see we got the right number. Power is greater on day 2 because she's taken less time to climb those stairs. Same work done on both days because it's same height, same force. So for the excellence, we need 4 correct calculations and correct statements regarding the work and power. So when we're talking about the 4 correct calculations, we are looking at, did you calculate the force? Did you calculate the work? And did you calculate the 2 different powers? So that's what we're looking at for the excellence. And then the other thing is just kind of explaining why her power is greater on the second day, and it's because she climbed the stairs faster. So this is what an excellence level answer is for this question. Not too bad. When it comes to breaking down the points, it's just a matter of, did you make a mistake in one of those calculations? Then you're up to merit. Correct statements about work or power. So you state something about how the power stays the work stays the same, or the power stays the same. For the excellence, you're stating both. Okay? And then achieve, there's lots of different ways you can get that. You can get that from calculating the weight force, doing one correct calculation, or one correct statement about work or power. We good? All right, so that question I think is fairly straightforward. The next one that I have to show you is looking at pressure. And we talked about this question last week, I believe, or the week before. So in this case, sorry about that. We were looking at calculating the weight force when we're comparing the Mars vehicle on Earth versus on Mars. So the mass of the Mars vehicle does not change, but the gravity that is being experienced does change. So we have the weight of the vehicle when we are on Earth versus the weight of the vehicle when we are on Mars. If you guys remember, we just did that force equals mass times gravity for both of those guys. So force equals 2,500 times 10. That'd be 25,000, where this would be Thank you. Oh, let me write the units down. Newtons. So the thing to remember between mass and weight is that mass is talking about the amount of matter, whereas weight is talking about the force that that matter exerts. So if I'm on a planet with less gravity, even though my mass stays the same, I'm exerting less force because there's less gravity pushing it down. Got it? Do you want me to repeat it? Lizzie? I can repeat it. I don't mind. That's right. You're right? Okay. Cool. The next thing they want us to do is to calculate the pressure that this object is going to exert when it's on Earth versus when it's on Mars. So things we have to keep in mind is that this is talking about the area per wheel, but we have to be mindful that there are 6 wheels on this vehicle. So do I need to multiply this number? Yes. How many? 6. So that's what I'm going to be doing as my first kind of step to figure out my total area. Area is equal 0.25 meters squared times 6. So 1.5 meters squared is the Mars rover touching on the ground. Are we good? All right, now looking back at our equations here. Whoops, wrong one I want. Okay, so we've gone through every equation but this one on the corner here. Again, it's another P equals equation. So both of these start with P, but they are different variables that they're looking at. Unfortunately, they didn't give them a new variable. So we used this one in the previous one, P equals work divided by time. In this case, I am talking about pressure, so I want to look at the force and the area that that force is exerted on. So when I'm thinking about pressure and how much pressure I'm putting down on something, if I am, you know how like there's like snow boots that have like, or snow skis, how they have that giant surface area? And then that giant surface area, you have your set weight that you have, or your force from your weight. If I spread out my area over a large sort of section, spread out my weight over a large area, then my pressure is going to decrease. So I won't sink all the way into the snow. So that's why things like skis have really large surface areas. So that way you stay on top of the snow, you don't sink down, because then you exert less pressure. On the other hand, if I want to do ice skating, I want to make sure I exert a lot of pressure onto the ice so that way I can like kind of cut into the ice and that way I can stay in my motion. So if you think about ice skates have a very narrow blade that's touching the ice. You still have the same force because you're still the same amount of matter. You still are on planet Earth, so you still exert the same weight on the ground. But the area is going to be far, far less because of the blade. So you're going to exert a lot of pressure onto that ice, which is really good because you want it to be able to move fast and to do your tricks and stuff like that on that. The other kind of thing to think about is shoes. So if you're wearing shoes like I'm wearing right now, which are flat shoes, I have quite a bit of surface area. If I swapped to wearing high heels, I then elevate some of my foot off the ground, so I have less of my foot touching the ground. I also have then the tiny little stiletto heel as well, and that's going to exert more pressure onto the ground. So when you're walking on like muddy, kind of wet ground, if you're walking on flat shoes like this, you sink less. But if I'm walking in high heels, I'll notice that my heels start sinking into the ground and creates quite a mess. So that's what we're thinking about when we're talking about pressure. So this Mars rover, we are thinking about the gravity in this case as kind of our deciding factor. So pressure is equal to the force divided by the area. So if I take the force on Earth, that was 25,000 divided by 1.5. So I am exerting as my pressure like 16,000, and then the unit for this is pascals. So quite a bit of pressure is going onto those tires, and my rover is going to sink quite deeply into the ground. Whereas when I compare it to Mars, and this is what the next question is asking for, the Mars vehicle is now on Mars instead of Earth, and we want to see if it's going to sink differently and why will it do that. Well, in this case, when I look at the pressure, my force, even though the mass is staying the same, is different. And the reason why my force is different is because there's less gravity on Mars. So I have the same item, but there's less weight to that item. Same area of the Mars tires. So we do the exact same calculation. We just swap out one number. And now my pressure is 61,000. Did I do that right? 61,000. Hold on. Oh, I added an extra zero, I think. Sorry, guys, there's one extra zero there. That makes more sense. There we go. Sorry, guys, I had an extra zero. That makes sense. I was like, why is that number bigger? It should not be bigger. And that means also this number needs to be fixed because there's an extra zero on there. Just make sure that number's right. Yeah, okay, I just added an extra zero. So you see how that pressure's less? So what that tells me is that the Mars rover is going to sink less into the ground on Mars. The less pressure from the Mars vehicle, and this is the result. Of the lower gravity. The vehicle doesn't change mass. or surface area. So the explain questions aren't too bad when it comes to mechanics, because you can prove a lot of what you need theory-wise by the math, which is good news, I think. Questions, concerns, comments? All right, I'll leave that up for you guys to copy. One or add them some. Right, move it. Lucy, ready for me to move it? Huh? Move it? Okay. No, it's these two as well. All right, let me just show you guys how the points break down, because I think it's always useful. So this is question number 3. Here we go. Hopefully I did my math right. I did. That's good. All right, so question D, they show us the calculation here, and this one they've shown us the same calculation. So again, use your math to justify when it comes to this mechanics. So excellence. Oh, you guys are going to love this. Super easy. Correct calculation using all 6 wheels. So basically, for this first question, D, if you calculated the 16,667, excellence point. No explanation, just can you do this math here? So nice, easy E point there. The other E point was on the second question, again, calculating the pressure, but this one was a little bit more tricky because you have to explain that it's going to sink less. So noting that even though the area is staying the same and the mass is staying the same, since there's less pressure on Mars, it's going to sink less into the Martian soil. So that's the excellence level answer there. The merit, correct calculation, but you forgot to multiply by 6. So that's going to be a key kind of factor that's going to make a difference between the merit and the excellence level answer, is whether or not you factored in the fact that there are multiple either skis or multiple wheels, that sort of thing. So read the question carefully. Don't rush. Take your time and go, ooh, actually, I need to multiply that by 6 because there's 6 wheels. The other one that they often do to try to trick you guys to merit to excellence is the units that they give you the information in. So, for example, they might give you area in centimeters instead of meters, and you're going to need to convert from centimeters to meters. So in that case, you will divide by 1,000. Just watch out for things like that, especially when they give you things like shoes or skis. Those things are measured in centimeters instead of meters. So be mindful of that conversion. Sometimes they give you the conversion to begin with, and you just have to be mindful of which number to grab. Again, achieve points. This is why I keep stressing it. Show your work. If you selected the correct formula, they would have given you the achieved point. They are very mindful that there were 2 formulas there that both start with a P. Grabbing the right one was going to be an achieved point. So show you're working, take a guess. If you're not sure what you're doing, just write down one of the formulas. Okay? And plug in some numbers. All right. For E, correct calculation using wrong area. So again, that error carries through. You forgot to multiply it by 6. The other thing that you could get for the merit is, even if you don't know how to do the calculation, but you could explain that the reason why it's going to sink less in Martian soil is because there's less force, then that would have been able to get you a merit point. Make sure you're using the word because, and you're linking these 2 ideas, less pressure because less force. And then lastly, for the achieved, select correct equation. Again, that's crazy easy for an achieve point. And then making a statement of same area, less force on Mars, sinks less on Mars. That statement would be an achieved. So keep in mind the difference between the achieved and the merit answer is basically taking this, like your achieved points, and linking them together. Because, therefore, are going to be your favorite words. Are we good? All right. That is it for me. when it comes to this question. So we have taught all the mechanics stuff. You guys have covered the whole content. All right, pick something to work on. We have about 10 minutes.